Welcome to Writing Java Agents for Fun and Not So Much Profit. My name is Robert Munteanu, and in the next 30 minutes, I'll be sharing my experience in writing Java agents. I'll be taking you through the hows, the whys, and especially the why nots. To get introductions out of the way, I work for Adobe in Switzerland. I'm part of the core Cloud Services Foundation team. I work in Java, Kubernetes stuff, mostly back-endy frameworky stuff. I'm also a member of the Apache Software Foundation. I'm active in a couple of projects, Apache Sling, Apache Jackrabbit. This is the schedule for today. This is what I like to call a sandwich presentation. So we have the slides that are the actual meat, and they're nicely wrapped in two demos. We go in for a quick demo to get a feeling of what we can do with Java agents. Then we're going to learn the basics of Java agents, get a little sense of what we have to do for different platforms to get Java agents up and running and what alternatives we have. Then we move to integration testing. Testing is quite a special subject when it comes to Java agents, and wrap up with yet another demo. So let's go to the first demo. If I can only manage to, oh, right. So this is a very, very simple Java class, Java application. It's as simple as it gets. You have a main method, and then you print hello world. And as we run it, well, print something else. Right, that was maybe expected since this is a talk about Java agents, but just to show you I have nothing up my sleeve. Right, this is the whole class and nothing but the class. And of course the answer is that I messed a bit with the launch arguments. So if I take a look at the JVM arguments, I see that there is a Java agent being added. But this is the essence of Java agents. You have an existing application source code compiled, and then at runtime, a bit of magic happens, and it does something different. Java agents are based on facilities coming from the Java platform. And the entry point to that is the Java Lang instrument package. And in our case, instrumentation means to altering the way, at runtime, the way a Java class behaves by changing its bytecode. The package is actually quite simple and self-contained, has a couple of exception classes. It has a data class, the class definition, and then two interfaces. And out of those, we only need to implement one if we want to write a Java agent is this class file transformer interface. The other one is for the Java virtual machine implementers. So how do we get about to define an agent? I think there are two ways of doing that. The first one I like to call a static agent, which means that we build our agent, we package it as a jar file, and when we start our Java application, we pass in a special JVM argument, which is called -Java agent, and then we give it the location of the agent jar on disk. And then the JVM does its magic. All the other arguments remain unchanged. In order for the JVM to know which class we want to define as an entry point to the agent, we need to add a special manifest entry, which is called pre-main class. And of course, this is a fully qualified name, a class definition. And then the class needs to look something like a little like this. So you have a pre-main method, which matches the pre-main class definition, takes this exact signature. The string argument is whatever the user has chosen to pass as arguments to the Java agent invocation. And the instrumentation, going a little bit back to the class definition, is that interface from the Java Lang instrument package. And our entry point. With this, we can add new transformers, which contain the actual logic of our agent. Option number 2 is what I call a dynamic agent. Instead of instrumenting the way you launch your application, what you can do is write a small piece of code that connects to an existing Java virtual machine and tells it to load a certain agent. And this is the exact API to do that. You get a reference, you attach to the virtual machine and tell it to load an agent. This argument is the exact same one as in the static agent approach. It has to be the file name of the agent jar. So no input streams, no bytes. The operation is mostly the same. There are two caveats with this approach. The first one is that this is a private API living under the COM sun space. And it usually works for hotspot implementations. In practice, that is almost all the Java virtual machines that you see in the wild today. The second one is that starting with Java 9, you can no longer use this code to attach to the JVM it's running in. Right? So you need to spin up a different JVM just to run this code and attach an agent. That can be worked around. I mean, both problems can be worked around. There are libraries that do that, but it's just slightly more inconvenient to do so. There also needs to be a manifest entry. So you now say agent class instead of pre-main class, pointing to the actual agent implementation. And in a way that is very much similar to the previous approach, you have an agent main method instead of the other one, and then you take the same signature, the arguments and the instrumentation. The nice side effect is that you can support both approaches in a single agent, right? The manifest entries do not overlap, the method signatures do not overlap, so you can support agents with both static and dynamic approaches. So how do we go about transforming classes? This is the interface that we need to implement for our agent. It's a bit of a mouthful, but I'll go through each of the entries in the method signature. Now, the first important one is the class name. Of course, if you run an agent, you may want to transform all classes, part of the classes available in the JVM, or just maybe one class. And you need to differentiate between them, right? And the simplest way to do that is ask yourself which class name I be invoked for, and that's the primary purpose of this parameter. And then you get a class loader, which is mostly used in environments that don't have a flat class space. So for basic applications, simple applications, you probably can get away without looking at class loaders. But as soon as you run into something more complicated or a modular platform, you need to look into class loader stuff. If you're running with Java security enabled, protection domain is something that you need to run for access checks. And then in some special cases, you have the class being redefined. If a Java agent says that it can redefine or retransform classes, then you get the old class object to inspect it. But in our case, we'll be looking at intercepting class definitions before they're actually defined. And this class file buffer is the current definition of the class before being instrumented. So you get in a byte array and you need to send out the byte array. So the byte array is what the bytecode actually contains on disk before being loaded. And you get intercepted, instrumented, and you return a new byte array, or you can just return null and say, I don't want to deal with this transformation. And that byte array is obviously a class file which is in accordance to the Java language specification. Just for explaining how things look, I took a bytecode listing using the Javapp utility from a Hello World Java class. Right. So this is just showing the main method definition, and then we have 4 distinct lines. First one is the get static opcode, which says gets a static field. It's the system out of type Java IO print stream. And then with the LDC opcode, we load the constant onto the stack, and it loads the actual hello world constant from the string constant pool. Finally, with invoke virtual, it invokes this Java IO print stream printline method, which ties in the field from here with the method argument, and eventually does return. Now, it doesn't look that bad, and maybe something I would consider hacking for a weekend project, but for maintaining it, you definitely want a bytecode generation library. The Java specification keeps evolving. The verifier can get more strict between releases, so we want to leave it to someone who actually does that for a living or for longer fun. There are a number of bytecode generation libraries. I do not necessarily endorse any of them. They differ in terms of the APIs, whether the API is high level or low level, in terms of community sizes, licensing, so you need to do the research and decide for yourself. For the purposes of this demo, I'll be talking about JavaSys because I think it has a nice balance between high-level and low-level APIs, and also is triple licensed, so it should be available for almost anyone to consume. And a simple transformation with JavaSys looks a little bit like this. So this is the body of the implementation of the class file transformer. First, we get access to a class pool, which is the entry point into the JavaSys API. And then from the class pool, we can directly get a method. We tell it this is the class name, and I want to work with the method main. And then we get to insert some Java code at the end of the method. And the nice thing is that we do not have to work with bytecode at all. We can simply pass it some legal Java code, and then JavaSys will compile it, generate the new bytecode, and give us that definition. Of course, it will throw compilation errors if we do not manage to write it properly, but then again, for me, it's much easier than working with various opcodes. We do this 2 bytecode call, which gives us the new class definition, and then we do a little cleanup, and the new bytecode is returned. Not shown here is the code that filters and makes sure that to only transform the right class, just because it's a bit too verbose. So now we've seen the hows, but why? I mean, what are the actual scenarios for writing Java agents? And again, this is a bit of an inventory. I think the one that we have been mostly using knowingly or unknowingly are code coverage tools. So if you're using Jacoco or Cobertura or Jacov or other tools, even though they're hidden behind Maven or graded tooling, they use Java agents. Whenever your classes are loaded, the befores and afters are instrumented so they can dump coverage data. Monitoring, also the type of system where you have a server somewhere and that is happily to get your error reports, your logs, your profiling data, and they just give you an agent, and then that agent, when you load it, says, oh, I want to instrument these classes, and I will ship off the data to the server somewhere. Profilers are sometimes implemented with Java agents. Debugging is an interesting topic. Let's say that you have a scenario where you have an application running in production, and every once in a blue moon it gets into a broken state, and it's hard to reproduce, and you need some more information out of the application. What you could do is dynamically attach an agent to your application and carefully rewrite it so that it dumps additional information. You can write log entries, you can dump the application state to a text file somewhere. Mocking libraries, sometimes it's not possible to mock everything, so if you have final classes, final methods, I'm not saying you should do this, but you could use a Java agent that allows you to mock these final things. Mockito does it, probably some others. And finally, there are some tools on the market that give you better hot reload than what is available then when you connect in debug mode with your IDE. All right, going through the basics, let's talk a bit about platform specifics. So what happens beyond the hello world of Java agents? I hinted on this before, so when you're doing running in a modular environment like application servers or OSGI environments, you cannot assume that you have access to the whole class space. You cannot assume that the Java agent running pre-bootstrap time has access to all the class definitions by default. And this is why the instrumentation API helpfully gives you access to a class loader. So instead of doing class pool get default and hoping that we get a class definition, what we want to do is construct a new class pool, and this true argument means we get access to the system class path. And then we use the class loader and construct a new loader class path so we can get access to all the class definitions that the current class loader has access to. And then finally, so we can rewrite the current the current class, we insert the class file buffer, which is like the current class definition before being transformed by us into the class path. And this is a safer way of creating class pool and accessing classes. Now, sometimes you can get away without actually writing a Java agent. Depending on your platform, there are certain facilities that you can use and, well, do the things that you want to do, or almost all the things you want to do without writing a Java agent. Spring has AOP, right? And that's a sort of a two-step approach. First, you declare a point cut which selects all the places in your application that you want instrumented. And in this case, we have all the executions of the service calls. And then you have the advice, the actual advice. So the change that you want to apply. And you can say, okay, before every web request, so that is the point cut defined before, have some logging. Now, what is, let's say, nice about this definition is that you have a very high-level domain-specific language of defining what you want to intercept and what code you want to add, as opposed to more low-level approaches in Java agents. It's a simplified programming model. It's much easier to deploy. On the other hand, it's a Spring-only solution, so if you're targeting a wide array of platforms, that's not feasible. And it doesn't intercept everything going on in a Spring container. It only intercepts calls to Spring Beans. If you're running on an OHI environment, there is a solution that is very close to the Java agents programming model. It's called the weaving hook. And the API is, the things that you get access to are mostly the same. The woven class gives you access to the class name, the old class definition, the bundle, a little bit of metadata, because in OSGI, just like a modular environment like the JPMS, you have extra definitions about the module or the bundle that contains the class being woven. So you can look into what module does this class belong to. Do I want to intercept it, for instance, based on the module and the metadata that is attached to it? So it's very, very similar to Java agents and a bit modularity aware. But of course, again, it's an OSGI-only solution. So if you're targeting a wider range of platforms, this won't work for you. So now we pretty much know how we want things to play out, but how do we test? There are a couple of challenges to testing Java agents. Packaging is the most obvious one. Right, you cannot run it as a regular library unit test by picking up the compiled classes in the target classes directory of your build, because you need to have a full jar. You need it packaged with special attributes. And also, Java agents are not easy to write in a way in which you can perform changes and roll back and still keep them performant and easy to follow. So that means that you need to learn there are possible solutions to this. One, it's a solution, not necessarily the solution to testing Java agents, is to just fall back to integration tests. You need to do a little bit of legwork and build your own testing harness. The steps briefly are: you launch a Java process from your unit test, from your test, it's no longer a unit test, and attach the Java agent to it. Then you need to establish a channel of communication between your test and the Java agent, whether it's the exit code or writing on the console and reading the output or opening up an HTTP server or whatever, right? You need to establish that communication channel. And additionally, you don't have support for all the additional enhancements that your build tool gives you, for instance, gathering code coverage. And a testing harness can look a little bit like this. First of all, you need to decide which Java binary you want to run with. I think it's a good idea to use the same binary as the one that runs your test. The reason is, one, it's more predictable. Two, it's easy to switch between different JVM versions by running the test with a different JVM version. And Java agents can be sensitive to the version of Java they're running with. So it's a good idea to run it, test it with multiple Java versions. Then you need to find the agent jar. It's probably tucked away somewhere in your target directory. There's a naming convention. You need to look for it, make sure that it is there. If you find duplicates, etc. Then you need to build a class path. Minimally, this needs to include the target test classes directory, but maybe you have external dependencies as well that you exercise when you run your test application. So you need to download them either ahead of time or dynamically place them somewhere and add them to the class path again. So it's starting to look a little bit like this. Let's build a process with the following arguments. Additionally, you want to communicate with your agent. So one possibility is have your agent dump things to system out whenever it's doing something or occurs a condition on which it acts. And finally, if you want to outcode coverage, for instance, using Jacoco in my case, you need to add another Java agent argument to the process you're launching. And very important, add it before your own agent, otherwise instrumentation will not happen. Now, this is not very wide use, but it does so much of what the test harness works with. So if you're doing OSGI, the PAX exam tests, they do 85% of what this testing harness does. It starts the application, it establishes a communication protocol. Even the test methods are executed in the context of the forked JVM as opposed to the JVM that runs the test. All right, let's go to the second demo. Now, this demo is based on a application on an agent that I have been working on, and it's here to help forgetful developers that make network calls using HTTP and forget to set timeouts, which can lead to interesting results in real life. Now, to configure the manifest, the Maven assembly plugin is simply going to add some manifest entries. You see there the pre-main class, the one that I have talked about earlier. And agents ideally need to be self-contained, so this is the jar with dependencies descriptor that comes built in. To make sure that we have the dependencies at test time, we use the Maven dependency plugin to just copy the dependencies and place them in a well-known directory. And to make things easier, when looking up, we just strip the version so we don't have additional complications. The failsafe plugin is here to run the integration tests, of course. And then the only actual production dependency is JavaSys. And then we have lots and lots and lots of testing dependencies, because this agent works with various HTTP client libraries. We need to test them all. So if you want to use OK HTTP, fine. If you want to use HTTP client 4, fine. We test with that as well. And notably here is also the Jacoco agent. Normally you'd be using it through a Maven plugin, but here you need to define it in the POM and download it so that it is accessible at test time. The launcher ends up looking something like this. So this is just a helper class. So this is the way we would, let me make that a bit smaller, the way we would find the jar, look in target, find the one that ends up with jar with dependencies. And then building the class path is taking the stuff from test classes and then looking for a whitelist of jars and adding them again to the test class path. Getting access to Java Home and then building like these large process arguments where we add coverage information, our own Java agent, the class path, and the rest are just application arguments. This is the entry point of the test harness, HTTP client launcher class, and the rest, they are arguments that go to the test harness itself. And when we want to actually run the test, we have this process launcher and we just wait for the process to complete. We dumped some information on standard out, just so that we know what the agent did, because we don't inherit the console output. And then we do what I call the communication protocol. It's a bit pretentious to say that, but it is a communication protocol. We look for the exit code and see whether we expected the agent to succeed or to fail. And then we parse the standard output. So what does this look like in practice? I don't want to run the whole test harness because it takes a bit of time, but instead I run the same test application. So this is a regular Java invocation. We attach our own agent and we pass it some arguments. That is the way the instrumentation API support passing arguments. You write an equals, and then whatever you write is up to you. Here, I chose positional arguments. So the first argument is a connect timeout in milliseconds. The second one is a read timeout in milliseconds. And the third one, if set, it just enters verbose mode. This class path is nothing special. This is the application. And then this is the URL the test application will be loading, and HC4 is instructing it to load using HTTP client 4. Now, when I launch it, you can see the agent writes some debugging information, and if the connection still works, it does. It prints out the headers. Now, what I can do now is start working with these arguments. Now, if I set the connect timeout of 1 millisecond, it will definitely fail. The code has been unchanged, but in the end, it fails. Connect failed, network is unreachable. If I want to simulate a read timeout and just alter the other parameter, it takes a little bit longer because it actually connects, but then it fails with the read timeout. And of course, the same thing goes if I want to use a different implementation class. It's a different stack trace. It's the slightly older HTTP client version 3. All right. Now, wrapping up, when to use Java agents for real this time. The first rule of the thumb that I use is, do you control the code or not? If you control the code, it's very much simpler to change the code, introduce extension points, etc. 2, do you have platform facilities available? We saw a couple, I'm sure there are more platforms out there that allow you this sort of global transformation to the objects they manage. So look into the platform facilities. And 3, ask yourself if you're doing sort of a global transformation with unknown targets, or do you have a one-off transformation of a couple of classes? Because if you're transforming just a couple of classes, you might be able to get away with forking the source code, make creative use of the class path or something else besides committing yourself to a Java agent. But if you do find out that you want to write a Java agent, you're going to have a little fun. I'm going to leave you some resources. Those are the packages that I've been talking about in the presentation, and also some projects that make good use of Java Instrumentation API. Well, with that, I thank you, and if you have any questions, feel free to ask them now. If not, I'll be around for a couple of days more. Thank you. There's a little argument parsing going on, and then we have a list of transformers that get installed. Each of these actually inherits a superclass, just to make it much simpler from an implementation point of view, that does some basic stuff like adjusting the class path, making sure that the class exists, and then there's an abstract method somewhere that says do transform class. And for this do transform class, we have something. So for HTTP client 3, we have a specific method we are looking for, and then we are inserting some method calls. There's a bit of JavaScript magic here. So if you say $_, then it means this, and then you set some parameters, and you construct valid Java code, and that's it. And there's also yet another abstract method that says, I will always update fields in constructor, because some libraries just work with updating the fields in the constructor. and you can just insert the methods, insert the changes in the constructor at the end of the constructor, and that gives us a couple of more HTTP client 4 and OK HTTP work this way. And that is basically it, I guess. There's a bit of code that handles JMX, so you can see some stats about the agent, but otherwise that's mostly it. Thank you.